Okay, let's unpack this. Imagine an AI model, one that doesn't just compete with the absolute titans of the industry. Think OpenAI speculated GPT-5, think Anthropic's Claude 4, but in some really crucial areas, actually outperforms them. And here's where it gets, well, really interesting. It does it all at a fraction of the cost.
Yeah.
Seriously, we're talking pennies on the dollar for tasks that usually cost, well, a small fortune.
Yeah, it's fascinating. DeepSeek V3.1 isn't just another AI model jumping into the fray. We could be looking at a potential paradigm shift here. This contender from a Chinese startup, it's showing what feels like a genuinely transformative advance. You've got this vanguard performance combined with unprecedented economic efficiency. It really challenges that core idea that cutting-edge AI has to come with an absolutely exorbitant price tag.
So how did this, well, underdog manage to emerge and challenge these giants? Today, we're going to pull back the curtain on DeepSeek V3.1. We'll dig into those bold claims about its superiority, look at the empirical data, the numbers that apparently back it up, and crucially, unpack the profound economic impact. What does that mean for you? Maybe you're a developer looking for better tools, or a business owner eyeing innovation, or maybe you're just like deeply curious about where AI is heading. We think you'll find some really eye-opening stuff here about how this could, democratize high-level AI globally. So in this just incredibly fast-moving world of artificial intelligence, DeepSeek V3.1 has really popped up as a game changer. It's an open source model, right,
Yeah.
developed by this Chinese startup DeepSeek. And it's not just sort of playing along, it's making serious waves. It's directly challenging the biggest players out there.
Indeed. And the core claim is, frankly, pretty remarkable. We're talking about an open source large language model, an LLM, with somewhere between 671 and 685 billion parameters. That's huge. But what's really notable, and the source material really highlights this, is that it doesn't just compete. In certain specific, quite important benchmarks, it actually surpasses giants like OpenAI's speculated GPT-5 and Anthropic's Claude 4. And the real headline, like you said, is this incredible economic efficiency. It's not just powerful, it's affordable.
And when we say affordable, the numbers are just, well, they're quite striking. We're looking at costs maybe around $1 for a complex task. Now, put that into perspective, right? For a lot of these frontier models, the training costs, the operating costs, so they can just soar into the hundreds of millions. So this isn't just, shaving off a bit of cost here and there. It feels like a fundamental shift. It could actually democratize access to top-tier AI for, well, almost everyone, making it accessible in ways we just haven't seen before.
Yeah, and if you step back and look at the wider picture, this achievement really could redefine the future of accessible AI. And sustainable AI, too. It directly challenges that sort of long-held dominance of U.S. companies in this sector. It's a signal that really significant disruptive innovation can come from, diverse global sources. And crucially, at a fraction of what we thought was the standard cost. This is a big moment, I think, for the global AI landscape.
Okay, the performance, the cost, clearly groundbreaking stuff. But the big question is how? How did they actually pull this off? How do you get that kind of performance for that low a price? Let's get into the engineering. What's under the hood here?
Right. A huge part of their success comes down to the technical design, the architecture. DeepSeek V3.1 is built on what's called a mixture of experts model and MoE. You can kind of think of a MoE system like having a big team of highly specialized experts. And for any given problem or input token, only the most relevant experts are actually activated to work on it. So in practical terms, while the total model has this massive parameter count, getting close to 700 billion, only a small fraction, maybe around 37 billion parameters, actually activate and do the computation for each bit of input. This selective activation is what really optimizes the computational efficiency, especially when the model is running during inference. It just means it runs faster and uses less energy.
That's a great way to put it. Like only using the specialists you need for the job, not the whole department.
Yeah.
So what other specific tricks or innovations did they build into this?
Exactly. So beyond just the MoE structure, they've integrated things like multi-head latent attention, or MLA. You can think of MLA as giving the model multiple very focused attention points all at the same time. It helps it process different parts of the input simultaneously, which leads to faster and often more accurate results compared to older attention methods. And their own system, DeepSeek Mo, is designed to make the training more economical. It gets rid of some common inefficiencies in how the workload is spread across those experts. It avoids things called auxiliary losses and load balancing, and it uses something called multi-token prediction, MTP. Basically, MTP lets the model predict several words or tokens ahead at once, which speeds up the learning and cuts down on wasted effort during training. That makes it much cheaper to actually build the model in the first place.
Fascinating. So it's not just about having billions of parameters, but deploying them really smartly. What about its memory? Like, how much can it keep in mind during a long conversation or when looking at a big document?
That's its context window. And it's impressive. DeepSeek V3.1 has a huge 128,000 token context window. For you listening, think of this like giving the AI an incredibly long short-term memory. It means it can handle really long, coherent conversations or analyze massive documents, even whole code bases, in one go without losing the thread, without forgetting what happened earlier. That's a pretty big deal for tasks needing deep understanding or sustained reasoning. And it's versatile, too. It's got functions for chat, complex reasoning, coding. It even has special tokens built in for grabbing real-time web info and for showing its internal sort of step-by-step thinking process. It's designed to be a real multi-tool.
That's quite a feature set, especially for an open source model. But what really drives this whole thing home is that stark difference in training costs you mentioned. The sources are suggesting DeepSeek V3.1 was trained for only about, $5.6 million, using around 2.8 million H800 GPU hours. You compare that to the speculated cost for something like GPT-5, over $100 million, it just puts the efficiency in sharp relief. So how do they actually achieve that level of cost saving during training?
Yeah, it's a critical question. And it really speaks to their deep optimization work across both hardware and software. The source specifically points to techniques like FP8 precision training. Now, without getting too technical, FP8 is about the numerical format used for calculations during training. By using 8-bit floating point numbers instead of the more standard 16-bit or 32-bit, they dramatically cut down the memory needed and the computational work. This lets them train faster, maybe with fewer or less powerful GPUs, which directly translates into huge cost savings. And importantly, they seem to do this without really compromising the final performance quality of the model.
So it's like a clever technical shortcut that dramatically reduces the need for super expensive computing power.
Exactly. A very smart trade-off. And the timeline itself is also remarkable. The entire training reportedly took less than 2 months. Using a cluster of just over 2,000 GPUs, you compare that to the many months, sometimes even years, needed for some competitors. You're seeing a huge speed up in the development cycle, which, again, adds to the overall efficiency and lower cost.
Okay, so the architecture sounds super optimized, training costs are incredibly low, but, the proof is in the pudding. Does it actually deliver on performance? This is where it gets real. The sources give us some concrete benchmarks. Let's dive into what the data actually shows us.
Right, and the data really does speak volumes. This is where DeepSeek V3.1 seems to truly shine. So take coding tasks. On benchmarks like 8 or Polyglot, it hit a 71.6% success rate. What's compelling there is that it actually surpassed Claude 4 Opus, which is at 70.2%. And it was right up there rivaling GPT-5's estimated performance, around 70%. Then you look at more complex competitive coding, like on LiveCodeBench, I got 40.5% in pass at 1. Shows real strength in certain mathematical problem solving. And on SWE-bench, the updated versions like V3.1 Thinking reached 76.3%. That's actually better than Claude 4. So the trend in coding is pretty clear. It's consistently right there with or even ahead of the top models, and always with that massive cost advantage, remember.
Wow. That's a huge statement, outperforming models built with vastly bigger budgets, especially in coding. What about general knowledge or
Sure.
more academic stuff?
Yeah, it's not just a coding specialist. For general knowledge on the MMLU benchmark, DeepSeek V3.1 scored 88.5. That's highly comparable to the leaders in GPT-4. GPT-4 got 88.7, Claude 3.5 Sonnet got 88.3. So it holds its own in broad knowledge, too, again, with that lower cost. Then in mathematics, specifically on the Math 500 test, it achieved 90.2% accuracy. This is really notable because it actually surpassed Claude 4, which scored 89.5%, and it beat other non-specialized models like Qwen 2.5, shows real strength in precise logical reasoning. And interestingly, in Chinese benchmarks like C-Simple QA, it also showed very strong performance, demonstrating good localized knowledge, again surpassing both GPT-4o and Claude Sonnet 3.5 there.
So the takeaway from these benchmarks seems pretty undeniable then. It's not just keeping pace with the top models, it's actually leading in really important areas like coding, general knowledge, specialized math, and often doing it for a tiny fraction of the cost. That's a really significant finding from the sources. Suggests a potential new era for performance to costs in AI. And this, for many people listening, is probably the most disruptive part, especially if you're thinking about building things with AI. Let's talk about the numbers that could genuinely make you rethink your AI budget.
Yeah, the economic savings are, well, they're genuinely profound. Let's try to quantify it. For a complete complex coding task, DeepSeek V3.1 costs roughly $1 or 1 cent, just over $1. Now compare that to similar systems. Depending on the model, the complexity, that same task could cost you anywhere from, say, $30 up to $70. That's potentially a saving of up to 68 times. 68. Just imagine running a big software project or an AI-powered customer service. Those savings would add up incredibly quickly.
That's incredible. So a startup maybe trying to weave advanced AI into their app, they could literally save tens, maybe hundreds of thousands of dollars by choosing DeepSeek V3.1 over established options. What about the inference costs for just general use, like processing text input and output?
Absolutely. It massively levels the playing field for startups and smaller teams. When you look at the raw inference cost, that's the price per token processed. DeepSeek V3.1 is charging just 0.49 per million input tokens and 0.28 per million output tokens. Now, to put that in perspective, that's dramatically cheaper than GPT-5 is likely to be, based on current pricing for similar models, maybe 1.7 to 1.3 per million dollar tokens.
Right.
Or think about Claude 4, that can be up to 15 per million dollar output tokens. So DeepSeek V3.1 comes in somewhere between 5 to 15 times cheaper than these big names. And this isn't just, about saving giant corporations money. This truly democratizes access to frontier-level AI. It lets startups, independent devs, even academic researchers tap into incredibly powerful capabilities without needing huge piles of cash. It really changes who can innovate at the cutting edge.
Okay, so what does this all mean for the bigger picture then? This isn't just about one cool new model. It feels like it's about shifting the whole landscape, challenging how things are normally done.
Well, what's particularly striking are the broader implications that the source material points to. First, the decision to release DeepSeek V3.1 as open source, putting it out there on platforms like Hugging Face, that's already led to really rapid adoption by developers all over the world. And this fosters amazing innovation, right? The community is already plugging into tools like chain-of-thought reasoning frameworks, pushing its abilities even further, even faster. But this model, just by existing and performing the way it does, it also poses a significant geopolitical challenge. It clearly demonstrates China's growing ability to rival the U.S. in core AI development. And that could potentially accelerate the global race towards artificial general intelligence, AGI, because it proves top-tier innovation isn't just coming from one place. Ultimately, DeepSeek V3.1 is being seen as a kind of catalyst for a genuinely democratized AI era. It's proving that excellence in AI doesn't have to depend solely on these exorbitant budgets and closed-off proprietary systems.
That idea of inclusive innovation is really powerful, isn't it? It's not just about the tech itself, but the potential to save companies millions, sure, but also to empower a whole new generation of creators and problem solvers, people who maybe didn't have the resources before. It really changes who gets to play in the AI sandbox. Of course, every breakthrough tends to come with its own set of challenges. DeepSeek V3.1 isn't likely to be different. We need to look at this with a balanced eye, a critical perspective. What are some of the hurdles or things to consider for its wider use?
Indeed, it's absolutely crucial to have that comprehensive view. Its strengths are clear, but the source material does outline several challenges. First off, there's scalability, or maybe accessibility is a better word. At around 700 gigabytes, the model itself is pretty hefty. It requires some serious hardware infrastructure if you want to run it locally. That means it might be tough to deploy in environments with limited resources, or for smaller organizations maybe lacking big computing budgets. That could limit its reach in some places.
Right. So while running it might be cheaper token for token, you still need some pretty serious kit to host it yourself if you go open source. What about the bigger world it exists in?
Exactly, and that links to the next point. Regulatory competition and geopolitics. In the current, let's say, tense global landscape, there's always the possibility of export restrictions or other controls affecting its global adoption, especially given its origins in China. Then, we absolutely have to consider environmental sustainability. Despite its impressive efficiency compared to some other massive models, training something this large still consumes a significant amount of energy. That raises important ongoing questions about its overall climate footprint. Also, practically speaking, integrating a brand new large model like this often takes extra development work. You need to customize it to fit smoothly into existing company systems and workflows. And lastly, there's a potential point about supply chains. Its dependence, potentially, on specific Chinese hardware for optimal performance could create vulnerabilities down the line, which is a relevant concern in today's global economy.
Those are definitely critical points. It's a reminder that even truly groundbreaking tech doesn't exist in a vacuum, right? The sources wisely seem to call for things like international collaboration, independent audits, ways to maximize the potential here while carefully managing these risks. It's really about responsible innovation, isn't it?
Absolutely.
Yeah.
And if we connect all this back to the bigger picture, DeepSeek V3.1 isn't just, an impressive piece of engineering. It feels like a statement. It fundamentally proves that a high-performance, truly frontier AI doesn't have to be prohibitively expensive. That opens doors for innovation all over the world, and it powerfully challenges those established narratives about where the next big AI breakthroughs will come from, and importantly, who gets to make them.
So, what does this all mean for you listening right now? Think about the implications here. If cutting-edge AI can genuinely be this affordable and open source too, what new ideas, what new businesses, what new solutions suddenly become possible? For anyone with a great idea, not just the organizations with massive budgets, this really raises a big, provocative question for the future. Is DeepSeek V3.1 helping usher in an era where the best AI wins based on merit, on innovation, on accessibility, rather than just on raw computing power in the deepest pockets?